Hello student, and SFBM lecture 4. Previous class we have already seen that the how can I draw the SFBM diagram with simple supported beam with point load. Now today we will see that how can draw the SFBM diagram in simple supported beam with UDL, means uniformly distributed load. Let's see here. We can see that it is a simple supported beam with UDL. UDL's what is the magnitude of the UDL? 10 Newton per meter, means uh, 1 meter length. The magnitude of the load is 10 Newton per meters. Mean length of the beam is equal to how much? Length of the beam is equal to 10 meters. Then total load of the beam is equal to how much? Total load of the beam is equal to 10 newtons into length of the beam is equal to 10 meter. That means 10 into 10 is equal to 100 newtons. In the beam we can see that there is a two supported, means point A and point B. Let point B is the reactions RB in upward directions, and similarly point B in the upward direct point A is equal to upward directions, reactions in RA. At point A, the reactions RA in upward directions. Now, we find out the reactions and reaction at RA and RB. First of all, we have seen that the total load of the beam is equal to how much? Total load of the beam is equal to 10 kilonewtons into 10 meter distance, means 10 into 10 means 100 newtons. 100 newton load carried by the two supported, means RA plus RB is equal to 100 newtons. It is clear. After that, the find out the value of individual value of RA and RB is equal to how much? Previous class we have already seen that we have taking a moment about some points. Now similarly here we can also the taking a moment about point A. Now how can I take the moment about point A? Let's see. Now taking a moment about point A, and the previous figure, if we see that the if you're taking moment about point A, the end of the B is equal to reaction how much? RB. Then RB into 10 is one moment. After that, taking a moment about point A, then total load is equal to UDL is equal to how much? 10 into 10, 10 Newton into length is equal to how much? 10 meter. So 10 into 10 is equal to total load, but we have taken a moment. That means you need to distance. So how much distance we will take? The distance you will take at the middle of the span. Why middle of the span? Because it is a UDL. When the UDL load is carried over a simple supported beam, the when you taking a moment, you must have taken the distance about the middle of the spans. That means total load 10 meter into 10, that means 100. After the taking a moment, middle of the spans means 10 by 2, then 10 into 10 into 10 by 2. After that, no load between this, then this is equal to 0. After that, similar calculation, it is a simple calculations. RB into 10 is equal to how much? 10 into 10 into 10 divided by 2, and RB is equal to 10 into 10 into 10 divided by 2 into 10. 10 10 cancels. 10 into 10 by 2, 100 by 2 is equal to 50. That means RB is equal to how much? RB is equal to 50. After find out the value of RB, this value, putting the value of RB in the equations, in below equations, RA plus RB is equal to how much? If we remember that total load is equal to beam is equal to how much? 100. Then we can easily write the RA plus RB is equal to 100. Then putting the value of RB is equal to the below equations, then find out the value of RA. Then RA is equal to how much? 100 minus RB. That means 100 minus RB is equal to 50 minus 50 is equal to 50. That is 50 Newton. That means reactions at RA is equal to 50 and RB is also 50. Then similar manner we can find out the SF, value of SF. After that find out the value of BM. How can I find out the SF? How can I find out the BM, value of the BM? Then for SF diagram, if we see that the previous diagram, so we can see that the SF at B is equal to how much? SF at B is equal to 50 newtons, and SF at the middle is equal to how much? If we calculate the SF at the middle, how much? The 50 newton at the point B upward directions, and if the middle of the spin span also, the load is equal to how much? Total load per meter is equal to 10 Newton, and distance how much from the middle of the span is equal to 5. So 10 into 5 load 50, then 50 to 50 is equal to 0. That means SF at the middle of the spin is equal to 0. The no SF means shear force no at the middle of the spin is equal to 0. After the similar manner, SF at A is equal to how much? Same similar. Already we have find out the SF at A by the by taking a moment. Then the is 50 newtons. Then we can see that the SF at B is equal to 50 and SF at A is equal to 50, and the middle of the span has no SF. That means as value of SF, when we draw the SF diagram, then we can see that the SF value at middle of the span is equal to 0. Before going to the draw the SF diagram, first of all we find out the value of the BM. How can I find out the value of the BM? The value of the BM, the what is BM? BM means bending moment. The moment about point about, and when we find out the moment of any point is equal to 0. If I already told you, the BM at the B is equal to how much? If we find out the BM at B, then if the force acting over the BM is equal to 50 Newton, but distance is equal to how much? 0. That means 50 into 0 is equal to 0. So we can easily write here the BM is equal to 0. Similar way, we can find out the BM at A also be 0. Then what is the value of BM at the middle of the spin? It is very important. How can I find out the BM at the middle of the spin? Let's see the BM at the at the middle of the span is equal to how much? The 50 Newton upward directions and 50 Newton from the if we find out the BM at the middle of the span, the if I stand the middle of the span, the right side, we can see the right side. How much load at the right side? 50 Newton is upward, and how much distance for the middle of the span is equal to 5. That means moment 50 into 5 and minus. Also, the span have a UDL load over the middle of the spans. How much? The 50 Newton load, 10 Newton load over a 5-meter distance. That means 5 into 10. That is a load, but distance is equal to how much? We have already told you that distance, when the find out the moment of the SFBM, the distance is would be middle of the span. That means the distance is equal to how much? 5. Then how much distance we have taken? The 5 by 2. That means 10 into 5 by 2 is equal to the BM at the middle of the span. That means total moment is equal to how much? Total moment is equal to 50 minus 5 minus 10 into 5. 5 means distance, and the distance 5 by 2 is equal to 125 Newton into meters. And similar way, what are the BM at the A? Already have told you the BM at the fixed point equal to 0. And also can I calculate the also can I calculate the BM at the middle of the sorry BM at A means 50 Newton upward, total distance minus 10, total distance 10, that means 50 into 10. Again total load is equal to how much? 10 into 10. Why 10 into 10? 10 Newton per meters, total length 10. Then 10 into 10 total load, distance is equal to how much? middle of the span, that means 10 by 2. If we calculate this, then we can value the we can get the 0. That means Bm at A is equal to 0. Now let's the diagram. For accept diagram, you can see that the if we have taken any scale from the how much the 50 kilonewton at point B, taken any scale, take 50 is equal to 5 units. So since 5 unit from upward direction, that is a positive, we have already told you. After that, Bm is equal to middle of how much 0? So 0, then draw a straight line. After that, similar Bm at the SF at the point A is equal to how much? Again 50, then join the again 50 will downward direction. One is upward, another is downward. Then again join the straight line. This box, this what two triangular box. This is equal to call the SF diagram, that means SFD. Similar way you can draw the BM also. Now see the BM diagram. BM at the 2 point fixed point is equal to 0, already I have told you, and the BM of the middle of the span is equal to how much? The maximum value 125. Before we here see that the BM is the curved natures. Why it is curved natures? Because when you draw the SFBM diagram, you note that when SFBM diagram in simple supported beam, if the load is UDL, means uniform distributed load, the BM is the parabolic nature, not the straight line. So when you draw the BM diagram, you have to draw the curve, not a straight line. So it is a parabolic natures. And when you show the SFBM diagram, you have to show the first of all loaded beam, after that SF diagram, after that BM diagram. Let's see the next slide. Here we can see that it is a example of this, like first of all we do the loaded beam, after that draw the SF diagram, then the BM diagram. But here we can see that one thing, see that the BM where the SF sign change. Let's see the SF diagram where the SF sign change means the SF value 0, but where the BM is maximum. That is very important point. The shear force is 0, but the bending moment is the maximum. That means chance of bending is maximum at the middle of the span, but the force, that means shear force, is equal to 0. This point you should be remembered when your uh, futures um, examinations or the an interview, when you can discuss the where the BM is maximum, you can answer that is where the shear force change its sign, the BM will be maximums. It should be remembered that. And next slide we can see that or more complicated problem or different problem we can discuss that one by one. So thank you.